So Maniifest is a TypeScript library for parsing presentation API 3.0 specifications in a type-safe way. And it has some helper functions to iterate over manifests and collections. Parsing manifests is quite complicated. It's fairly straightforward. If you have limited use cases, you can roll your own solutions, but to handle more general use cases requires some understanding of the specifications. It gets more complicated with the addition of W3C web annotations. So type safety is a way that we can ensure that a program only performs operations on data types that are valid and compatible. So if we take the canvas properties of height and width, we would expect those to be a numeric type and not, for example, a string type. That would be a type error. To model the V3 presentation specification, we'll do this in a formal way using a domain-specific language. A domain-specific language, or DSL, is designed to be very simple and effective for a particular use case, unlike, say, a general-purpose language like Python. And we're going to use adjustable type definition, which is a language for defining data types across different programming languages. So we'll model the presentation API in this language, and then we'll compile that into TypeScript code capable of parsing our IIIF specifications. The same technology is actually available within the Mithi web annotation server. This is what the current ATD DSL looks like. We have a series of types and properties that can be optional and choices between various types. So a target could be a single item or an array, and then each actual target could be a choice of, in this case, a string, or a more complicated example, a specific resource, which has a bunch of properties such as a source, and that source could also be a URI or an object with some extra properties. So if we look at an example of using Maniifest, we want to build, for example, a content search service where we need to take all the annotation text and index it, or we want to take all the annotation text reference from the manifests and collections and send them to an LLM to generate some vectors for a semantic search service. And we use the welcome collections collection because it's nice and complicated, and it references annotation text at line level. We're going to need to handle this nested collection, and we're only going to use 3 iterators from Maniifest. The benefit of using iterators is they allow for lazy evaluation, which is a memory efficient way for working across these large structures. So the actual collection is a collection which consists of nested collections, which in turn consists of references to manifests. And if we go into the manifests themselves, we can then go through and access the Canvas W3C annotations. And this is where we're going to get the line level text from these annotation pages. If we open one of the manifests in a viewer, this is how the annotations render. And let's finally look at the code that will process the welcome collections collection. And it consists of, as mentioned, three methods, and there are 3 iterators. iterate collection manifest. This will go through the collection and find all the manifests, no matter how deeply nested they are within that collection. Once we obtain our manifests, we need to then iterate the content of the manifest itself. In this case, we're going to iterate the canvas and the W3C annotation pages within it. And then finally, we can iterate over the annotation pages themselves and access the annotation text body content. And if we run this code, we'll see that it will produce the line level annotation text. And this is limited to 5 manifests, but you can see it's still considerable amount of text. And the link to Manifest is here on GitHub, and there's also a online checker you can use for your specifications, and a link to Miffy Annotation Web Server. Thank you very much for listening.
John is here. So while that was being recorded, John is here to answer questions at the end. Up next, we have HDR images via Image API by Christian Mahnke from Projektemacher.
Please let me just start my slide. Yeah, I have a small problem regarding the presentation of my ideas and findings. It's currently not really possible using something like a Zoom or any other software for video conferencing. The reason for this is that I'm going to talk about images with a higher bit depth than 8-bit per color. So let's start. Yeah, my topic is about HDR images using the IIIF image API. That was the topic that I proposed, but in the meantime, things have changed. So actually, this is a talk about promoting the topic HDR to, well, have somewhere in the future way to add it to the specification to provide HDR contents, not only images, but everything HDR related. What is HDR? Some of you are certainly aware of it. There have been around for about 30 years composed images from multiple exposures that was called HDR. And those are images which have a higher dynamic range. This is what HDR stands for. And this allows you to capture actually more colors than usually with a conventional digitization hardware. Very short and incomplete introduction. We can talk about this slide later on, I guess. I was starting to tell you about the recent changes, which basically is that HDR technology is coming to consumer devices. Certainly, some of you are aware of it, that your smartphone can at least take HDR images and videos. Modern ones can also have a HDR display, even if you are not using it quite often. That's currently just because there are not that much contents yet. And HDR is also coming to the to 3D models. For example, in gaming, this is not that new. It has been around for about 10 years by now, given the hardware support is right. But well, it's getting better all the time. There are some limitations, at least for HDR support on the browser, and that's my main focus here. this is at least three requirements need to be fulfilled. You need the software support like the browser. You need operating system level support. This is certainly currently the best on macOS. Linux support, Windows support works for gaming, at least if you enabled it explicitly, and Linux is not that good currently. Browser support is surprisingly about 95% for images. That's due to the fact that Firefox is in decline since years, and almost every other browser is actually just a repainted Chrome. And support from open source tool chains like Vips or ImageMagick and some others is coming. ImageMagick already has some limited support, and Vips will be around the next release, I guess. To display HDR images, there's a technique which is called gain maps, which is currently the way to go. It's just working by separating HDR and SDR components, where SDR stands for standard dynamic range. This is just a normal image. Those gain maps are defined by displaying a difference. That is usually just some sort of grayscale map to indicate where higher or where brighter areas of the images are. And this technique is implemented already, at least on vendor side, in certain or several image formats like JPEG or AVIF and so on. There's a specification coming. And this separation has one benefit. It allows the fallback for non-HDR devices. So you can view such enriched images in your normal browser or on your normal desktop and don't have any distortion, but you just see the normal HDR images. And another thing is that this allows some efficient storage. Or just in case you're asking, why do I bother you with HDR technology in this field? From my point of view, it's a great visual effect that allows to create stunning looks for cultural artifacts. In the next slides, we see some examples. I guess I skipped the demo session since I'm not sure how well the hardware support on your side is, but there are links in the presentation where you can see the examples in full effect if you have the supported infrastructure. This is not only this can not only be used for just highlighting things, but also for combining multiple image sources. We'll see an example later on. And my examples are focused on cultural artifacts, and but this is not limited to it. Other ideas might be things like scientific visualization. I wrote down some examples. Also, it's possible to do some on-the-fly image operations in virtual research environments, for example. And it's not only limited to web browsers, but this is my primary focus here. To enable the support in your browser, as I said, some things are needed. You might need to set up or you might need to configure the enable experimental web platform features. Down in the slide, there's a link. I can post it later on in the chat. And these are the demos. You've already seen the wallpaper. This was the first example. This is a full IIIF enabled image API presentation. The other examples are not yet IIIF enhanced, I would like to say. It's a beaker made from uranium glass. I'm not sure if you're aware of it, but there was a time when people used uranium to color their glass. which has an interesting effect. If you use ultraviolet light and shine it on the glass, then it starts to glow in green. And other examples are some image enhancement or contrast enhancement, better to say, for an old copybook, and some example that I created from public domain images from the Metropolitan Museum of Art. Below you see some two images combined, one in visible light and one in X-ray. And this one in X-ray is used to highlight the colors in the visible light beyond the scale of the standard definition range. This has an interesting effect that the woman, Venus, has a head more since it was overpainted, the head. It's visible in the X-ray light, but not in the visible light. And you see a large crack in the image, but the link is also, or the full image is also linked in the demo section. And now the thing that I've talked in the beginning, I'm here to promote this. So there has been in discussion on GitHub. Glenn is currently, as far as I remember, trying to organize a meeting, but we as a community want to know if there's interest in providing such technology within IIIF. So basically, I would like to ask you to either send me a mail or join the GitHub discussion if you want to know more or if you want to contribute in this effort. Thanks.
Thank you. That was great. Okay. So up next, we are going to hear from Ruven Pillay with TIFF image encoding for IIIF, optimizing for size, speed, and quality.
Thank you. I'm Ruven Pillay. I'm a researcher at the TypeScript and author of IIIF Image, which is a widely used IIIF image server. So TIFF image encoding for IIIF, optimizing for size, speed, and quality. So TIFF format is a very well-established, flexible, and mature format that's widely used within the IIIF community and beyond. How a TIFF is encoded and structured can make a large difference to file size as well as to decoding speed. So TIFF supports a number of both lossless and lossy compression options. However, there's a lack of published empirical data on performance. So the goal of this talk is to look at the compression options that are available and to look at the performance characteristics for each one with respect to typical IIIF use. So the presentation is related to work carried out by the HTJ2K working group, which looked at JPEG 2000 and published and presented in previous IIIF conferences and meetings, looking at the performance characteristics of HTJ2K and also on how to encode optimally JPEG 2000. So if you're interested in JPEG 2000, please check out these references. One of the things that came out of the benchmarks we carried out was that although TIFFs don't compress as well, they are much faster to decode. So why is that? Well, TIFF has a number of interesting features that make it a perfect format for cultural heritage and for scientific imaging. It supports multiple bit depths. You can store images in several ways, a strong metadata support, and in particular for IIIF use, you can encode your TIFF using a multi-resolution tiled pyramid structure. So in this kind of structure, you store multiple resolutions along with the full-size image, and you tile each of these resolutions. So when you're doing pan and zoom viewing, you only need to decode the region you're looking at the resolution you're looking at. So TIFF is able to support any type of compression. However, only a certain number are explicitly listed in the original specification. However, the de facto reference library libtiff supports a few extra types. So for lossless encoding, you have LZW deflate, Z standard, WebP. For lossy encoding, JPEG or WebP. So LZW deflate and JPEG are widely supported in both commercial and open source software and are part of the official TIFF 6 specification. Z-Standard and WebP are more recent. They were introduced into libtiff in version 4.0.10, which was released in 2018. So that's already 6 years ago. You should note that JPEG and WebP only support 8-bit images, whereas LZW, Deflate, and Z-Standard are more generic compression formats and can compress any type of data. So we're going to be testing uncompressed versus lossless versus lossy compression, comparing file size and encoding decoding speed. We're going to use a set of high resolution images, typical IIIF images of museum artifacts. We can encode each image using VIPs. For timing reasons, we run each encoding 3 times and average the timing. Our test environment is Linux-based, running on bare metal and on a high-end production server. So let's first look at file size. So we have lossless encoding on the left, lossy on the right. Our y-axis is the ratio of the compressed size relative to the raw data size. So 1 is the original uncompressed pixel data. So we can see that to create a uncompressed tiled multi-resolution pyramid TIFF, you have quite a bit of overhead for the multi-resolution structure. So you have about 40% overhead. You can offset this by compressing, and we can see that LZW and Deflate improve this by about 30%. Z-Standard can do a little bit better, and WebP can do actually really well here. It can compress this right down to about 60% of the original data size. I've included JPEG 2000 just for reference purposes, and we can see that JPEG 2000 lossless is actually very competitive here. For lossy encoding, we're aiming for a quality factor of 90, and we can see that JPEG within TIFF compresses to about 30% of the original data size. And interestingly, WebP can match or beat JPEG 2000 here. So for both of these, we've aimed for a quality factor of 90, which is similar to JPEG. And we can see that these both perform really well and that WebP is actually competitive with JPEG 2000. If we look at encoding speed, our y-axis is normalized so that uncompressed tiled multi-resolution TIFF is equal to 1. So we can see that something like Deflate takes about 12 times longer to compress. Here, WebP is actually off the scale. I had to cut this off. It's about 10 times slower than everything else. So this is way off the screen. In terms of lossy encoding, JPEG performs really well. WebP is several times slower. But compression only needs to be carried out once offline. So in most cases, encoding time is not an issue. It's decoding time, which is the most important criteria for use with IIIF. So we're going to use a test methodology which is very close to what we used for the JPEG 2000 tests. So random IIIF tile requests made at different locations and resolutions for different high resolution images, resulting in 5,000 requests in total. And as a test framework, we use IIPimage, which provides precise microsecond timing information for each internal process. So let's look at our decoding times. Again, we've normalized our y-axis such that uncompressed tiled TIFF is equal to 1. So what we see here is that Deflate is about 14 times slower than uncompressed TIFF. The thing that stands out in particular here is Z-Standard. Z-Standard is a compression format which is designed to be fast, and we can see that it is indeed fast here. It is much faster than any other compressed format. WebP performs similarly to Deflate, and LZW is actually much faster. Now, in terms of lossy encoding, JPEG performs quite well, and actually WebP is not so far behind. So can we reduce decoding time even further? So IIIF image servers usually decode the source image, then re-encode to the desired output format. This, of course, is necessary if any image processing needs to be applied, but is slow and unnecessary for simple pan and zoom use, which happens to be the majority use case for IIIF. So what if we could avoid this decoding encoding cycle and have both small file sizes and fast decoding speeds? Well, IIPimage version 1.3 will have a new low latency mode which eliminates the decode encode cycle and outputs almost raw TIFF tiles. This, of course, only makes sense for browser native types such as JPEG and WebP, and of course only works for tile requests that exactly match the underlying TIFF tiled multi-resolution pyramid structure. So this is ideal for pan and zoom use and gives you performance that's closer to uncompressed TIFF performance. So conclusions: if speed is critical and storage space is not an issue, use uncompressed tiled multi-resolution pyramid TIFF. If you're creating derivative TIFF images for IIIF use, you should definitely consider using one of libtiff's new supported codecs. For lossless compression, Z-standard is very fast and compresses better than LZW or Deflate. WebP lossless, although it has the best compression, is way too slow to be practical. IIP images new low latency mode will significantly improve latency for JPEG and WebP compression, and lossy WebP provides excellent compression and quite reasonable decoding performance. But if you combine this with version 1.3 of IIP image, WebP provides actually quite an optimal combination of both good compression and very low latency. So we have a server release of version 1.3, hopefully in early 2025. So if new features such as this new low latency mode, a new fast efficient JPEG decoder so you can use JPEG images directly without transcoding to TIFF, new output formats such as AVIF and other enhancements and bug fixes. For more information, visit our website and don't hesitate to get in touch. Thank you.
Great. Okay, and up next we have zip files for tile delivery from Rhyno at the University of Windsor.
Hi there. I'm going to talk to you about one option for using IIIF on a budget. With lots of help from my employer, the Leddy Library at the University of Windsor, I have been a volunteer with a project called Our Digital World for about 15 years now, and most of my work is on historical newspapers. Our Digital World grew out of an initiative called Knowledge Ontario, which was a multi-sector effort coordinated by the Ontario Library Association. The provincial government pulled the plug on the funding for Knowledge Ontario in 2011, and Our Digital World has been a standalone nonprofit ever since. Ontario is a big province in Canada and has a long newspaper history, but even for someone with a mother who worked as a reporter and who owned a community newspaper for a dozen years, I was overwhelmed by the volume of newspapers that digitization efforts can uncover. This is a partial inventory of the newspapers that we have worked on from Essex County, which is a fairly small county at the tip of the province across from Detroit, and we have identified nearly 200 titles so far. The potential scope and scale of historical newspapers is staggering. I should also note that the collections I work with are mostly static collections. Our Digital World also provides a platform called Vita for organizations that have ongoing newspaper projects. In happier times for newspapers, they really were the record of the community. I also think newspapers can capture transitions really well. For example, this advertising from the early part of the 20th century captures a time when Ford wasn't competing with Chrysler or Chevrolet. Ford's biggest competitor at that time was the horse. The examples are endless for what newspaper content can capture, and this is why it is so important to try to make them available. So for lots of reasons, we want to find low-cost options for newspaper digitization. Two building blocks that we have become interested in are web storage and container computing. I purposely did not use the words cloud storage here, since we have some use cases where these might be newspapers served in-house on an internal network. The key is the notion of a URL accessible file source, which could be AWS storage or even a local machine with Apache on it. Container computing is a more intricate topic than we can get into here, but I like this graphic on the right, which is from a nonprofit-facing web services company called Reclaim. Container computing is the idea of paying for computing services based on use without requiring a lot of the overhead associated with provisioning those services in advance. This means that we want to serve tiles from web storage and to streamline the number of files this requires. The two strategies for making this happen are based on some very long-standing technologies. One of these strategies is to use byte ranges, which have been part of web server plumbing since the late 1990s. On the left of the slide, we can see how these requests work, basically requesting part of a file rather than the whole thing, which is often very useful for efficiency and common in functions like streaming and transferring large amounts of content. On the right is the zip directory structure. Library tech folks may find it eerily similar to MARC communications format, which is used for bibliographic records. The zip format has been around since the 1980s and is a well understood and documented format. We have been zipping static tiles for single pages into one archive and combining all of the zip pages for an issue into one file, which the zip format allows. This avoids having hundreds of files and folders for individual issues, which makes managing the volume easier. In the early days of Knowledge Ontario, we often had newspapers with thousands of files since we used a tile approach that predated IIIF and was arguably even more prolific in tile generation. One surprise with our current approach is that even without compression, the zip archive is still significantly smaller than the tile layout on its own. This seems to be related to the volume of subfolders used in IIIF. Somewhat in the same vein of the info.json file in IIIF, we've been trying a JSON format that gives the offset information for working with the zip files. We're providing this information for two types of zip archives. One is the tiles for IIIF, the other is called blocks, and we use this for providing imagery for highlighting newspaper page snippets and search results. We can do this by linking the OCR to the snippet identification, a process that is more simple than it sounds, but only matters if you are folding in a discovery layer. For IIIF, zipped archives of tiles can largely be handled in the browser. We have an example of this in GitHub using OpenSeaDragon. The advantage of this approach is that it is one less task for the container or server to carry out, and it helps that OpenSeaDragon already supports the notion of a custom tile source. This process is described in more detail at the GitHub site. The other approach is to have the container pull everything together. We have an example in Node.js on GitHub for this as well. Node.js and browser-based JavaScript are almost identical, and it's really a question of deciding where assembling the tiles is most strategic. We may pursue a hybrid of both in-browser and node tile extraction. A lot depends on overhead and understanding container costs better, which we are just starting to get a sense of. We also recognize that there are use cases where organizations have newspaper collections that would benefit from digitization, but where external access may be problematic and where budgets are razor thin. One problem that we are hearing more about is vinegar syndrome with newspapers on microfilm, where an organization is looking for digital access to the content, but may be some ways from being able to make the title available outside of the premises. So running Apache and Node.js on a single machine is an option that we want to support. Finally, and at the same time, we are excited by the promise of container computing. It's not a great time to be in the server business, and our digital world and its partners have been sideswiped by a number of cybersecurity incidents. Container computing can help make a lot of the upfront costs of deploying an application more reasonable, and hopefully open the doors for more organizations to pursue digitization. And that's it. I'm easy to find if anyone wants to follow up with me directly, and we are always open to collaboration with others. Thanks for listening to this presentation.
Okay, thank you, Art. So unfortunately, we have to make a change to the program. One of our presenters, Izzy Barrett-Lally, had a last-minute issue arise, so we will do our best to try and get her to send us a recording of her presentation, and we'll incorporate it in the final one that we'll share on YouTube. So with that, I think we can move into Q&A. If you would like to ask a question out loud on camera, we would ask that you just raise your hand in Zoom so that we can manage it that way. If you'd rather not speak and you want to type your question into the chat. Glenn and Martin and I will do our best to manage them there. And maybe while people are thinking about this, I have a question, which Art, you kind of, you mentioned having a cybersecurity issue at the end there, but didn't really elaborate. But I'm curious what kind of problems you're encountering, just because it's front of mind for a lot of people in the IIIF community.
Yeah, well, I think we've sort of been touched by several incidents, but one was at the university where I work. We had most of our systems offline for about 3 months at one point, and it was, you know, it's tricky with cybersecurity incidents because no one really ever wants to say what exactly happened. And it's very vague on what the circumstances were. But I think it's pretty common knowledge it was some sort of ransomware attempt, and we did survive it. But one consequence of that is that server-side solutions are frowned on very heavily at my organization. And I think that happens a lot with especially smaller organizations where, you know, it's hard to get server people at the best of times. And that's why we become quite interested in container computing, just that it helps alleviate that problem. And we think it's a lot cheaper.
Great. And Neil at the British Library has helpfully posted a link to the very detailed report that they shared following their cyber attack. Yeah. And Anna Marie made an interesting point, which is in terms of digital repositories that use IIIF viewers, there are AI chatbots that are crawling so aggressively that they take us down or slow down our repositories. So they've had to block specific ones since they disregard robot requests not to crawl. Other questions? Yeah, Anna Marie, you can unmute.
Hi there. So I manage a Samvera digital repository at Ohio State University, and I've been enjoying watching the presentations to see how people reuse content in repositories that use IIIF manifests. And so as somebody who's coming from this in a different angle, what can we do to make reuse of this content easy for all of you? Because it's great seeing the different ways that people reuse this content in really creative and meaningful ways.
I mean, I have thoughts on this, but maybe we should give our presenters and others a chance to talk. Say if you have something to say now, you could just pipe up. No? So Anna Marie, can I ask, are you specifically talking about how you can facilitate reuse among this community or reuse among researchers, or does it not matter to you?
Any of it. I'm just enjoying this and trying to see how we can support it from the other side, because we often get research requests. And so, for instance, our IIIF viewer right now, we've turned off file downloads. That was a decision by curators, but there's still an eagerness to support researchers, and there's been a lot of brilliant presentations, and I think that's something I want to share with my colleagues, that this is something meaningful that we can share. So that's why, if there's anything to keep in mind.
Yeah. Well, maybe I'll start off and say that I think the IIIF community in the last maybe 18 months or 2 years has made a concerted effort to do some outreach to those not end users, but the people who are reusing and facilitating reuse of IIIF resources, rather than just speaking to the technical folks who are doing the implementation. So some of that is just basic IIIF literacy. What does IIIF stand for? If you see the IIIF logo, which I would say having that in your repository is helpful, you know, in the UX, and then demoing what you can do. The IIIF education group has done really heroic work in advancing IIIF among that community of people, researchers, and then also students. I don't know if others have anything to add here.
One thing that's come up with newspapers is we hear from students, usually AI students or students in computer science, that want these massive data sets for some sort of machine learning project or something to do with text processing. And one common request is that they want everything, right? So, you know, we have the Border City Stars, 135,000 pages, and a student will say, well, I'd like all of it. And one technology that comes in quite handy is just having a search engine to sort of better curate what goes back to the student, because they usually have some sort of vocabulary they're working from to form the basis of the files that they're going to feed to their machine learning algorithms or whatever. So, you know, I think indexing is still a powerful tool for things that are largely textual in nature, just to reduce the file sizes, because it's still, bandwidth is still a hard problem in computer science. It's hard to get terabytes of content to researchers.
Yeah, Anna Marie.
So I think one thing I'm curious if people are aware of is, like, in the library field, we often use OAI PMH, Open Archives Initiative for Protocol Metadata Harvesting. Sorry, I've got a cat climbing all over me. So, but that's where I'm interested if people are aware that you might be able to get IIIF manifests from these data sets that we have in via Open OAI PMH. So there is a lot of capabilities there when you're trying to get hundreds or thousands of records and get that. So I didn't know if there was some crossover there where people were aware of that, or if that's something that we need to do more in the library community to, you know, cross-share information.
So maybe I can add. So we did look at OIPMH when we were looking at the IIIF change discovery API, which allows to do the similar sort of thing to OIPMH, but it's in a JSON format. So it can allow the large kind of harvesting of a large amount of content. But the downside, I think, that Art mentions is it means a lot of downloading and crawling, which might make it time consuming for very big data sets.
Yeah, it also kind of rolls into the next question, which is anyone giving attention to the environmental impact of IIIF generally, like we are with AI?
I'll just sort of quickly weigh in on that. We did have a presentation at the Los Angeles meeting that touched around that. And Neil Fitzgerald just put a link into the Digital Humanities Climate Coalition. But I think this would actually be a very good topic for a future presentation. So if anyone out there is interested in exploring this topic, it would be really great. And we can see how we can help with that in terms of research and things like that. But I think this is an important topic, and it would be great to actually have a concerted exploration of the topic.
Yeah, it's specifically going to be in the call for proposals for the next in-person meeting. So we are eager to hear more on that.
And Mike Appleby just noted that cloud providers often have dashboards to help evaluate infrastructure.
I'll just say definitely for AWS, and I think also for Azure and Google, you can find numbers. Whether you believe them is another thing, but they'll tell you your overall sort of carbon footprint for your cloud use, and then they'll also tell you how much that they've contracted for green energy for. So again, what goes into those numbers, I don't know, but you can find them. And I think it's interesting to look at our overall footprint, not just IIIF, but in everything we do in libraries and museums, cultural heritage. So it can be a useful tool for that. It might be hard to break out IIIF if it's just one part of a much larger set of cloud infrastructure that you're hosting.
Okay, other questions? All right, just try and give people time in case they're typing, because I would hate to cut someone off at the end. But it doesn't look like anyone else has anything to add. So with that, I'm actually going to turn it over to Martin to close us out.
I want to thank everyone for attending over the last few days for both the presentations and the workshops. Special thanks to today's presenters, Ruven, Christian, John, and Art. And then again, also all the workshop organizers over the last couple days. And special thanks to Caitlin for riding herd over all of the different Zoom links and the presenters and getting all the information up and running. Glenn for his work also. So we're really looking forward to the upcoming annual meeting in June. Hopefully we'll see some of you in Leeds there in person. So again, thanks for attending, taking time out of your day to attend these 3 days, and I'm looking forward to seeing you online or in person. Any last logistics, Caitlin, in terms of links and follow-up?
No, so I will say we've tried to collect links in Slack, in the IIIF Slack in the 2024 online meeting. There are a few more that I'll have to upload at the end of today. And then recordings will be lightly edited and then put on the IIIF YouTube channel. And unfortunately, that is reliant on when I have a chance to do it, hopefully before the end of the month. But if you have any questions or you need to ask a question of a speaker or anything else, please don't hesitate to reach out to the staff. Thank you all.
Thanks again.